Okay, everyone. So in section 2.4, we're going to be discussing the difference between a relative maximum and a relative minimum, and an absolute maximum and absolute minimum. So let me go off to another page real quick and show you the difference between the two. Suppose I have an xy plane, and suppose my function kind of looks something like this. Let's say the function looks kind of like that. Then we have a bunch of bumps that we call extrema. So these are all extrema. This one is what we call a minimum. Here's another minimum, and this one would be called a maximum. Now, this maximum is not the highest point on the whole graph, so we would be calling it normally a relative max. So the difference between the relative max and an absolute max is the relative max is kind of like a high point in the little neighborhood, but there are obviously higher points, like all these ones over here are higher, all these ones over here are higher, so that's why we usually call it a relative maximum. Okay, so far so good. Whereas the same concept applies to the minimum. So like this minimum over here is not the lowest point on the graph, so that would be called a relative minimum. Okay, so a relative minimum is not the lowest one on the whole graph, but it's a low one in its own little neighborhood basically. Now the minimum over here is gonna be the lowest one on the whole graph, so this is what we call an absolute minimum. So absolute minimum. Okay, so far so good. So that's basically the difference between the word absolute and relative. So if you're not sure, just say minimum or a maximum, and that will take care of it, and it will still be right. Okay. Now the next concept that we're going to talk about is what we call the extreme value theorem. So let me give you what let me give you an idea of what that looks like. So let me scroll down here, and let's talk about the extreme value theorem. So when we're talking about the extreme value theorem, again, we have the xy plane. So let me draw the xy plane. This time I'm just going to focus on a section of the graph called AB. So I'm going to focus on a section from A to B. So suppose I have a function that starts kind of like over here and ends, I don't know, maybe like over here somehow. And suppose the function is connected all the time between A and B. So at A, it starts at that little dot. At B, it ends at that little dot. And you have to draw the function without lifting your hand off the paper. So no matter how you do it, suppose we do this, or suppose we do this. Doesn't matter how you do it, any of these red or blue curves will have a maximum or minimum. Even if you try to make the graph straight, you're going to have a maximum or minimum. The first point is going to be the minimum on that graph. The last point is going to be the maximum on that graph. So regardless of how you do it, there's a maximum somewhere and there's a minimum somewhere on the blue curve. That's it. On the red curve, this would be the minimum and this would be the maximum on the red curve. So regardless, you're going to have a guarantee of a maximum or a minimum. Okay. And so the extreme value theorem, that's what basically it says, extreme value theorem. Now for this to work again, you need to have a function that is continuous. So the function f of x has to be continuous. All right, let's go ahead and practice that with one of the examples. So here we go. It says find the absolute maximum and minimum of the function f of x equal to x cubed minus 3x plus 2. So we will start the same way as usual. We will start by finding the derivative. The derivative of x cubed is going to be 3x squared, the derivative of 3x is going to be 3, and the derivative of 2 is going to be 0. Let's factor this derivative by pulling a 3 out, the GCF, and we get x squared minus 1, which is the same thing as saying 3x minus 1 and x plus 1. Okay, so what makes the derivative... So now what makes the derivative equal to 0 and what makes it undefined? So f prime of x is equal to 0 when either the x is equal to 1 or the x is equal to negative 1. So those are the two values that make each of the parentheses equal to 0. Once you find out what those values are, those are what we've been calling so far in this chapter critical numbers. This one should be x equal to negative 1. Okay, so once you find the numbers, you're gonna say which one of those guys belongs in the interval 3 and 1. Well, both of them will belong in the interval. Now, is there a chance for the f prime to be undefined? So f prime to be equal to 0. Is that possible? Could it be 0? The answer is, in this case, no. There are no way that this derivative can be equal to 0. Now, usually we draw the negative infinity, positive infinity, and when we put the critical numbers on the line, we will not be doing that for this problem. We will be doing something else instead. That's because the interval that they gave us right here is what we call a closed interval. So if you notice, there's a bracket at the beginning, a bracket at the end. So this is what we call a closed interval. So when we have a closed interval, the process of deciding who's max and who's min relies on using a calculator. It's basically a little bit faster than doing the whole, the whole line with everything else, with the pluses and minuses and so on. Okay. So what we're going to do is start by putting the -3, which was the very first number right there. So that's the first number in my interval. So I'm going to grab it and put it into my table. Then next thing I'm going to do is put in the critical numbers in order. Let's say, -1 and +1. And the last thing I do is put the last value from my interval into the table. But in this case, it happens to be matched with one of my critical numbers, so that's pretty much it. Okay. So next, we type in to the formula x cubed minus 3x plus 2 into the calculator, and we estimate what the values are for each one of these x's. So I'm going to give you a chance to put this in your calculator next. So I'll pause here for a second. Put it in your calculator and try to estimate what these numbers have to be using the table feature in your calculator. So did you get -16, 4, and 0? If you did, that's awesome. If you didn't, double check that you typed in the right thing into your calculator. So the f of x of this problem should be x cubed minus 3x plus 2. So now we're basically finished. All we have to do is look at the -16 and 4 and 0 and decide who's the biggest number, who's the smallest number, and that's basically it. So -1 gave me 4, and that was the biggest number out of the 3, so we're going to call that the maximum. -3 gave me -16, that was the smallest number, so we're going to say the minimum is at -3. So in other terms, what we're saying is if you graph the function on the xy plane from the point -3 to the point 1, you're going to be starting very, very low, and at -1 you're going to be kind of high, and at 1 you're going to be back to 0. So the graph kind of looks like this. So there's a maximum right here, and the minimum is at the start of the graph.